density, mass and volume. In today's lesson, we will be looking at working out density, mass and volume. It is a high-level GCSE topic, so let's have a look. You need to know what density is, mass is and volume. Well, first of all, mass just means weight. And you know what volume is, don't you? Volume is, well, in a 3D shape, you want to know the volume of it. So how much there is in a 3D shape, you could say, or for example, how much you can fit into a 3D shape, or the measurement inside a 3D shape, that's volume. And then density, well, density is the amount of mass in a volume. Okay, it tells us how tightly matter is packed together. So, for example, you can have something like this. Okay. Or you could have something like this. Okay. The most common units when we're looking at density is grams per centimeters cubed. As you can see, it's the amount of weight in a volume. So obviously that's weight, and then volume, obviously centimeters cubed, or kilograms per meters cubed. Okay, these are the two most common units used when looking at density. Now there is a relationship between density, mass and volume. And to do this, you can remember it as a triangle. So if I draw myself a triangle, okay, and you will have seen a triangle like this before. Sometimes when you're doing trigonometry, you can put them in triangles, or even the most common one you will know of is speed, distance, time. In this situation, mass, density, and volume. Okay, and we can see from here that if we were to work out the mass, we would do density times volume. If we were working out density, we would do mass divided by volume. And if we're looking at volume, it would be mass divided by density. Okay. So let's have a look now at some examples. Okay. So I'm just going to write some examples out. Okay. So we've got a block of cork. A block of cork has a volume, and I will draw this out so you can see as well, of 600 centimeters cubed and a mass of 204 grams, and we are working out the density. Okay. Okay, so a block of cork has a volume of 600 centimeters cubed and a mass of 204 grams. Now I can draw myself a little block here. Okay, if I want to. Okay, now the volume, I can write it just so I can see it, is 600 centimeters cubed, and the mass is 204 grams. Okay, first things first, when you have a question like this, draw your triangle out. Okay, so MDV, what am I working at? I want to work out density. Well, to work out density, I've got to do mass divided by volume. So mass divided by volume, I know what the mass is, it's 204. I can work out the volume, which is already given to me, 600. So I can just divide this on my calculator. So 204 divided by 600, and I end up with 0.34. Now it's grams per centimeters cubed. Okay, grams per centimeters cubed. Make sure you get the correct units, otherwise you won't have the correct answer in the exam and you won't get the full marks. Okay, that is the density. Let's have a look at another example then. So this time we'll do example number 2. Okay, so we've got a cube of ice this time, a cube of ice of side 2 centimeters has a mass of 7.36 grams, and we are working out the density. Okay, so again, what I would do is, first thing, I would draw myself my triangle, MDV. Again, we are working out density. So circle density, well, the left over one is mass and volume, and that line there means divide. So to work out density, I've got to do mass divided by volume. Well, it tells me the mass is 7.36 grams. However, I don't actually know the volume, so I've got to work out the volume in order to take this question further. So you would get extra marks for this question, obviously, because there's one extra step involved. It says a cube of ice of size 2 centimeters. Well, a cube is made out of square faces, isn't it? And a cube, all the sides are the same. So to work out the volume, it's length times width times height. Well, they're all the same, aren't they? Because it's a cube. So 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. Okay, 8 centimeters cubed is the volume. I now know the volume, so I can divide. So I can do 7.36 divided by 8 on my calculator, and I end up with 0.92. Let's get the measurements correct. It's grams per centimeters cubed. Okay, that is the density. Okay, so again, let's have a look at another example. We'll do a few easy ones, then we start looking at some GCSE style questions. Okay. Let's do question number 3 this time. Okay, so cuboid has dimensions 9 centimeter by 3 centimeter by 2 centimeters. Okay, it has mass. It has a mass of 194.4 grams. Okay, and we are working out the density. Okay. Okay, first things first again. Draw your triangle out. Okay, MDV. We want the density, so we're left with mass over volume. Again, similar to the last question, I've got 194.4. I need to know the volume, so I just times these together, don't I? So I do 9 times 3 times 2 to give me 54. Oops, that wasn't supposed to happen. Divided by 54, isn't it? Okay, so 194.4 divided by 54, and I end up with 3.6, and it's grams per centimeters cubed. Okay, and there we are. We have worked out our answer. Okay, rightio. Let's have a look then at another example. Okay, so this time we'll say, we won't work out the density, we'll work out something else. So we say a cuboid again this time has dimensions 2 meter by 90 centimeters by 140 centimeters, and it has a density of 0.8 kilograms per meters cubed. Find the mass. Okay, again, first of all, what I would ask you to do is draw your triangle out. Okay, MDV. Okay, well, we are working at the mass. Well, to work out mass, I've got to do density times volume. Well, I have the density. The density is 0.8. I've got to now times it by the volume, but I do not know my volume of my cuboid, but I do know the measurements of my cuboid. So let's have a look. My measurements are 2 meters by 90 centimeters by 140 centimeters. Now just have a look here. We have a bit of a problem. I've got a measurement in meters, I've got a measurement in centimeters, and I've got a measurement in centimeters. So we have a problem here. Now, we have to have a look and note here that we've got difference of units, haven't we? Now, we need to choose our units, haven't we? Very carefully. Now, I could convert the 2 meters into centimeters, but that would be incorrect because just have a look at the density. The density is 0.8 kilograms per meters cubed. Okay, so there's a hint already in there that we need to have our measurements in meters cubed. So that there, I've got 2 meters. Well, I've got to change 90 centimeters now into meters. That would be 0.9. And 140 centimeters in meters would be 1.4. Okay, so now I can times this out. So if I times that together, I'm going to do 2 times 0.9 times 1.4, and I end up with 2.52 meters cubed. Okay, that is my volume. So now I can times that because they're both the same, in the same units, times by 0.8. And when I do that, I end up with, on my calculator, I end up with 2.016, and the measurements would be just kilograms because mass is just weight, okay? And density was in kilograms, so obviously that is going to be in kilograms. Okay, lovely. Let's have a look at another example then. Example number 5. So this time we're going to use a different shape. So we're going to say a cylinder has a mass of 270 grams. That's weight. It has a density. Oops, let's get rid of that. It has a density of 0.78 grams per centimeters cubed and a height of 9 centimeters. And we're going to find the radius. Now, this is an example of a GCSE high-level question because you're not just working at the mass, you're not just working at the density or the volume. There is more to this question. Now, you've got a cylinder. It's told you the mass, it's told you the density, it's told you the height, and you are now working out the radius, basically. So first of all, again, I'm just going to zoom out of here. What I would say, ask you to do in this situation again, is still to draw your little triangle out. So we've got mass, density, volume. Okay, right. In order to find out the radius, we must know the volume first, okay? Because obviously, we can work out the volume, we can work out the radius if we know the volume. So let's have a look. So volume, I'm just going to draw myself a little cylinder here at the side as well, so you can see. Okay, like that, okay? Because you know, we've got the height here, which is what, 9 centimeters. And I'm going to want to know the radius, okay? Right. To work out the volume here, I've got to do mass divided by density, haven't I? I've got to do mass divided by density. Well, I know both of those things. I know my mass is 270 grams, and I know that my density is 0.78 grams per centimeters cubed. So straight away, I can divide that, 270 divided by 0.78, and I end up with 346. And I'm just going to round it on my calculator to 2 decimal places, 15 centimeters cubed. Okay, now that's not it, okay? We've just worked out the volume. Now, how do I work out the volume of my cylinder? Well, I know to work out the volume of my cylinder, it's area of base, okay, times by height. Okay, right, area of base. Now, my area of base is a circle of a cylinder, obviously, times by the height. Well, how do you work out the area of a circle? Well, to work out the area of a circle, I do pi times radius squared, and I'm going to times it by the height. Well, pi, change the color of the pen. So pi times radius squared. What's the height? The height's 9. All that is equal to the volume. But I know what my volume is. My volume is 346.15 centimeters cubed. So let's replace that. 346.15 equals pi r squared 9. Now, I can do that because in maths, I do not have to write down the time sign, do I? If the number and the letter are together, that just means obviously the relationship there is multiply. I'm just going to write that in a different way. 346.15 equals 9 pi r squared, and that looks a bit right. The first one there looks a bit odd, obviously because we have the number before the letter, don't we? Now, I just want to be left with the radius here. So you can do this in two ways. You can either get rid of the 9 pi in one go, or you can get rid of it. You can get rid of it one by one. I'm going to get rid of it in one go because that obviously means 9 pi times radius squared. How do you get rid of a times by 9 pi? Well, you divide by 9 pi on both sides. Okay, so here I've got 9 pi divided by 9 pi. That's going to cancel. So I'm just left with, I'm going to leave that as a fraction for now because I want the accurate answer. Okay, equals radius squared. How do I get rid of a squared from a letter or a number? Well, to get rid of a square, you square root. Remember, you've got to do it on both sides. So I've got to square root 346.15 over 9 pi. That'll give me the radius. So tap that into the calculator then, and let's have a look. I've got 346.15 divided by 9 pi, and then I've got to square root the answer, and I'm left with 3.498935824. I'm going to just round this to one decimal place, 3.5, and let's have a look up at centimeters. Okay, just went a bit too further up. There you are, centimeters. So centimeters. I'm just going to write for the examiner one decimal place like this, so they know that I've rounded to one decimal place. Now, this was an example of a more tricky question, okay, that you would get in the exams, and obviously, a question like this would be towards the end of your paper. Let's have a look at another question then before we leave. Okay, example number 6. We're going to say liquid A. Okay, liquid A has a density of 0.7 grams per centimeters cubed. Liquid B has a density of 1.6 grams per centimeters cubed. Then 140 grams of liquid A and 128 grams of liquid B are mixed to make liquid C. Work out the density of liquid C. Okay, so let's zoom out a little bit so you can see the question. Okay, draw your triangle MDV. Okay, well, we're working at density, aren't we? To work out density, I've got to do mass divided by volume. Now, it tells me that I've got to mix liquid A and liquid B together to make liquid C. Yeah? Okay, well, first of all, I want the liquid C, the density of liquid C, so I've got to mix the mass up for liquid A plus liquid B, and then the volume of liquid A plus liquid B. Okay, but liquid A mass, what's the liquid A mass? Let's have a look. Oh, we don't know that, do we? We just know the density. We want to work out the density and we want the mass. So let's have a look. Oh, hang on a minute. We do actually know, don't we? What do we know? 140 grams of liquid A. Okay, yep. Okay, so that's the mass, isn't it? 140 grams. So see, you've got to really think about a question like this. add that together. Okay, but I do not know the volume. That's it. I do not know the volume. So I need to work out the volume of liquid A and liquid B. So to work out volume, I've got to do mass divided by density. Okay, so let's have a look. My mass here is 140 for liquid A. We're doing it for liquid A here. And my density for liquid A is 0.7. Okay, and if I work that out here, I'm going to do 140 divided by 0.7. I end up with 200. Okay, centimeters cubed. And if I want the liquid B, I'm going to have to do the mass, which is 128, divided by its density, which is 1.6. Can do that on my calculator. 128 divided by 0.6. Oh, and I end up with a recurring decimal, 0.3 recurring. I'm just going to write that as 33. Okay, so I'm going to add that up now. 200 add 213.33. Okay, so the first one, 140 plus 128, I'm left with 268. I can add the bottom one up, 200 plus 213.33. That gives me 413.33. I can divide them now, 268 divided by 413.33. And when I do that, I'm left with 0.64839, 0.65 I'll do, and it's grams per centimeters cubed to 2 decimal places. Okay, and let's just double check that on my calculator. That is correct. 140 divided by 0.7, always double check your answer. 128 divided by 1.6, and I end up with, oh, I've got a problem here. I have made a mistake. That there is 280. So sometimes what can happen is when you click that onto your calculator, you don't get the right answer. So I've just added that to get 280 because just divide that out again for you. Let's have a look. When I divided this, I actually got 80. Okay, so that's where I made a mistake. So if I just divide that now, 268 divided by 280, and I end up with 0.9571428, 0.96, and it's grams per centimeters cubed, and there is my answer. So an important thing like this is make sure you always double check your answer at the end, because obviously you can make a mistake. There's a lot going on here. You know, I've had to work out the volume for two liquids and add them together. So all I did was I went back and checked. I did 140 divided by 0.7. I did get 200. But when I did 128 divided by 1.6, I did not get the answer that I got previously, which meant that I made a mistake. So I needed to go back and check that. So these were a few examples of looking at the density, and then obviously we worked at the mass and the volume as well. Popular GCSE questions that always pop up. Make sure you use the triangle when looking at questions revolving around mass, density, and volume. I hope this lesson was useful for you. Thank you for watching.